What is up, guys? DevCode here. Today we're going to be talking about getting set up for the first time so we can get started. So in my previous video you saw that I was using this piece of software here, which is called CLine. CLine is basically a pretty nice program that I actually use to do all of my C++ development. You could use others. It really doesn't matter the platform. But personally, I think this one's the best because it allows you to do a bunch of things in terms of debugging that are a little bit more difficult on other programs, and it's a little bit more intuitive. Not to mention, this is kind of the similar layout to an Android Studio, which I also use, so it's more comfortable for me. Alright, so if you're thinking about getting CLine, it actually isn't free. There's a little bit of a fee for it. You can go to pricing. I believe they have a lower cost for students, so you can definitely check that out. Alright, so now once you have CLine downloaded, you don't really have to do any tweaking of settings or anything. You can just jump straight into developing. So in order to create a new project, we're going to go here to New Project, and let's call this Test Project. New window. Alright, and that's it. That's pretty much all you have to do. Now, if you don't want to go through this process of creating your own separate project, you can actually go to my GitHub page. Go to github.com/androiddevcd/sharp. This is actually my repository, so give it a fork and check out to branch remastered. That's what branch we're going to be working on, to where you can then kind of keep up with me in terms of all the commits and stuff like that. But moving forward, there's a couple things that we need to change in our project in order for this to start working correctly. Now, there are already tutorials out there on using CLine, so if you want to learn how to use the software and how it works, I will put links to how to use those in the description below, but I'm just going to go through the basics and go from there. So first thing we need to note is we have this CMake list.txt file. This is going to be your CMake file. If you don't know what CMake is, I will also put that as a link in the description below. You don't really need to know it for the purpose of this video series, but it does help to understand it. I'm actually going to go back to my previous project, the one that we're going to be working on. Now, in your project, if you decided to create your own project from scratch, really all you need to do is copy the very code you see here into your project file. So you're going to copy all of this code into your CMake.txt file if you don't pull it from my repository. And basically the important things to note in this CMake file is that we're going to be using C++ 11. The reason for that is it has a couple of different libraries and stuff in there that make coding in C++ a little bit easier. So that's kind of why we're going with this version of C++. Another thing to note is the executable. So the way that we're going to make our programming language is we're going to have standalone executables that are going to be created for us to be able to basically build the executable and be able to give it to any other machine that operating system it supports on, and then run it without needing DLLs or standard library shared object files. So this build shared libs off flag and this exe linker flags static. Basically what this is saying is we want all libraries that our executable is utilizing to be put inside of the executable. That way we don't need to reference any outside files. So once our executable builds, everything that exe needs to do to be able to run our programming language is going to be contained within inside of that file. Yes, there are other ways you can do it, but this is the way that we're going to do it. Another thing to note is what's called build variants or build configurations. I actually don't know the technical term for it, but basically in CLine, there are a couple different ways you can build your executable. So there's one called CMake debug. There's another called CMake mini size release, which is basically build your application in release mode, but shrink it down to the most minimalistic size that it can have without needing to have external references to things. Next, what we also need is we need to add a definition called -d make compiler. The -d basically signifies to the CMake compiler that's processing this file that we're saying that this is a global variable or a defined variable that can be accessed within inside of our application. So if we go to my main.c++ file, we can do if defined make compiler. So basically what we can do is we can write out if defined make compiler, and if this variable is found, then whatever code is inside of that if block will then be compiled. So we're going to need that for the future. We won't need it for the purposes of this video and some future videos, but it will be used later. And that's it. So now what we need to do is we need to start setting up our project structure so we can start to build our programming language. Now, what we need to do is we need to go up here and create a new folder called lib. Then inside the lib directory, we're going to create a new folder called grammar. And this is basically going to be the folder that's going to hold all the code for our compiler. Then we need to create a new directory called Runtime. This is going to be the folder that's going to have all the code that's going to house our runtime engine. Finally, we need to create a new directory called util. And this is going to be a folder that contains basically all the files that are going to be used by both folders, and it wouldn't make sense to recopy a C++ class from one folder to the other and just simply put it in util. So this one is basically like a bridge for both of these two folders. Now, the styling of the folder directory structure doesn't matter. It's just the way that I've developed my programming language, and it somewhat keeps everything organized, so it's a little bit easier. Alright, so now that we have everything set up the way we need it to be, now we can actually start getting into building the programming language. When it comes to using CLine, basically the only things that we're going to need to use are this, which is called build configurations, which I will go over in a little bit, the run button, and the debug button. That's pretty much it. CLine is pretty convenient because it also lets you do version control within the actual IDE, which other IDEs do, but this is more familiar to me because of my background with Android Studio. Alright, so when it comes to building a compiler, this is a topic that I've often seen in forums that is very shaky, because people who do this are often people with years of experience in computers and electronics. Most of them have degrees, some of them, or a lot of them, have PhDs, and they really have a lot of knowledge about compilers and how computers think because of their experience. But a lot of them don't really go into detail about how those mechanics work because it is a lot at first. Now, since this topic is pretty complex and advanced, I may bounce around a little bit, and if I do, definitely let me know in the comment section below so I can get back on track. But I'll do my best to explain to you guys everything I can about programming languages, how they work, and how to build one on your own. So if you go on a forum and you type in how to build a compiler, this is probably the first thing you're going to see, which is everyone telling you to read the Dragon book. This is a very boring book, not to mention it's $170. This is a very big hardcover book that really does go into detail about compilers and how they work and how C++ was built and the underlying mechanics behind that. So the concepts and ideas that I'm going to be teaching you in this series aren't going to be exactly 100% to the T, because I'm self-taught when it comes to building a programming language and compilers. However, I am fairly close to what the Dragon book and some of these other engineering books that teach you about programming language design say. So before we start to write any code, we kind of have to understand at least a little bit about what is a compiler and how compilers work. And there's a term that you may have already heard before That's called bootstrapping, and that's what we're going to be doing to our programming language. We're essentially going to write our programming language in programming language A, write a compiler in programming language B, and have the compiler compile programming language A, which then Next up is a video that I found on YouTube that really helped me understand how to build a basic runtime engine for my programming language. This video is by a guy named Terrence Parr, who is actually the founder of the tool called Antler. And he basically goes into detail about how a virtual machine is built and how it runs. I would also highly recommend you to watch this video about how to build a virtual machine, because once we get into building the runtime engine for our programming language, it's effectively going to be a virtual machine that stems from the roots of what Terrence Parr is talking about in this video. There's also an article that I found online about how to create a virtual machine in C++. This was actually the first virtual machine that I had ever written in C++ and marked the beginning of me building my programming language. This article basically talks about two different types of virtual machines: stack virtual machine and a register virtual machine. So if you scroll down to where it says required software and you click on register virtual machine in C, it'll take you to a wiki page which will explain what a virtual machine is, how it works, and how to code it in C++. This file was also the fundamental foundation for how I ended up building my virtual machine to run my programming language that I have today. I would also recommend you checking out this wiki article. Finally, we need to understand the anatomy of a compiler. And although it may seem like I'm grazing over a lot of complex topics, it really isn't all that complicated. Sometimes people try to overcomplicate programming languages, compilers, virtual machines, and runtime engines, but in its essence, it's actually not that difficult. This was literally the only article that I used to learn how to build a compiler. If you try and find resources online, which I've searched for high and low, there really aren't any resources that have a fit and finished version of a compiler written in a dedicated programming language that shows you how to build it from start to finish. In this article, they will talk about something called a parser. That we'll go over in a little bit, but basically, as they're explaining what a parser is, they mention something called flex and bison, or lex and yak. And basically what those are tools that you can use to build a compiler to make things easier for you when it comes to building a parse tree and parsing your tokenized data in order for you to interpret those parse trees and then generate some code to be outputted. But in this video series, we are going to use all of none of those, because I personally feel that not only do you learn more by creating your own compiler from scratch, but you also have more control over how the compiler works. So all the links for all of these resources will be in the description below, and I would highly recommend you guys check all of these resources out before continuing with the video series, because it will just make things a whole lot easier for you. Alright, so now that we've gotten all of the pre-work done, now we can actually get started on laying out the groundwork for our programming language. What we're going to start on first is we're actually going to start building the compiler first. And the reason for that is we need to have a concept of how the language looks and then the ability to be able to write code in the language before we start writing the system that it's going to run on. So the first thing we need to do is we need to create our runtime class. So I'm going to go here, create a new C++ class, call it runtime. And in our runtime class, we're going to create a public function called bootstrap. And basically what this function is going to do is this is going to be our entry point for our compiler. So now we're going to go into our runtime file and create our bootstrap function. So now we're actually ready to start coding our compiler. So the first thing we need to do is we need to have an if statement to check the arguments to see if we're being passed anything to our compiler. So we want to check to see if argc is less than 2, and if it is, we want to call the help function. then we want to return 1. And this 1 basically means that our compilation process was not successful. So now what we need to do is we need to create the help function. So I'm going to hit Alt-Enter and create the new help function. And in this help function, we need to write out some of the options that we're going to be giving to our compiler. So the first thing we want to do is we want to output the usage of our compiler. So what we have to do is type cout usage bootstrap. Alright, so now that we have this, we're getting a couple of compiler errors. So what we need to do to fix this is we need to update our std imports file to import the proper library to output data to the console. So I already have here a couple of different imports that we're going to need to use. So just copy these down and then take this file and include it in our runtime file. To make things easier, instead of putting the std imports include inside of the runtime file, put it in the runtime header file. That way, whenever we need to utilize this runtime header, we don't have to import the std imports file in that C++ file because it will already be imported in the header file. If you noticed, I use certain font here for the usage of this help statement, and this is standard when it comes to building a program in C++. Next, we need to tell the user what this compiler expects in terms of input. So we basically want to say source file must have a .sharp extension to be compiled. Next, what we need to do is we need to start writing out the different options that we're going to provide for our compiler. I've written out a couple of different options that we're going to be using. We're going to have an option -v, -show version, -o, which basically means what is going to be the name of our output file, -c, which means compile only, -a, which means use aggressive error reporting, -s, which means strip our executable file, -o, this is a capital O, which means optimize our file, -w, which means disable all warnings in the compiler, -v, which means set the application version that we want to run, -u or unsafe, which means compile unsafe code such as assembly code, object dump or objDMP, which basically means dump an object file of the output so that we can see what was generated. Target, which I think this is actually the one that specifies the runtime that we want to run on. -v is just giving your application a version. WError, which means all warnings that are delivered through the compiler, set those as errors. -release or -r, which means generate a release build, which means we do not want source code to be at the bottom of the output file. And -h or question mark, which means help. Now, at the end of this video series, each and every last one of these options should work in the compiler. So now that we know and understand what each of these options mean, now we have to write a description of what each of these do. So for -v, we want to say print compiler version and exit. Next, for show version, we want to say print compiler version and continue. For -o, we want to say set the output object file. For -c, we want to say compile only and do not generate executable. -a, enable aggressive error reporting. -s, strip debugging info. -o, optimize executable. -w, disable all warnings. -v, we want to set the application version. Unsafe, we want to allow unsafe code. Object dump, we want to create dump file for generated assembly code. For target, we want to target the specified platform of Sharp to run on. For target, we want to target the specified Sharp platform to run on. So if we ever create a newer version of a virtual machine for Sharp, and we want to run our code on an older virtual machine, we can specify that using the compiler. WError, we want to enable warnings as errors. Release, we want to generate a release build for the executable. And finally, -h, we want to display this help message. Now, to make this a little bit more prettier, I'm going to space out all of the semicolons because we need to add inlines at the end of all of these anyway. Next, once you do that, you basically want to add an inline at the end of each of these cout statements, and then you should be good. So now that we have our help message, now we're ready to start writing the code for our compiler. So I'm going to stop here, and we're going to continue where we left off in building our compiler. So hopefully you guys enjoyed the video. Definitely like and subscribe to the video if you guys enjoyed it and you guys want to see more. So until next time, I'll see you guys later.